Okay, dear student, welcome to my lecture. Today we will learn about the B plus tree. In the last lecture, you have so far find the B tree. So B plus tree is a variant of B tree, but there is a significant difference between B tree and B plus tree. In B tree, all the nodes are same, where there are only one single node, which is called root node. From there you are setting the direction of going left and right. In the B plus tree there are two types of node basically. So one is called the data node and one is the pointer node. So the pointer node, which are basically contains the data which are among from the data and selection only the path where it is going through, and the leaf node, which is called the data nodes, contains all the data. Suppose there are some datas. From the among the data you have to choose one selective data for a pointer. From that you are selecting where the data is found from the left or the right. So that is the mainly difference between B tree and B plus tree. So there are two types of leaps. So the advantage of B plus tree is basically keeps the key in sorted order for sequential traversing, uses a hierarchical index to maximize the number of discrete, uses the partially full blocks to spend insertion and deletion, keeps the index balanced with the recursive algorithm. So that is all for the B plus tree, because B plus tree having the two level of trees, two level of leaps. Basically one is mentioning the direction and another one is containing the data. So there are two things which is containing the direction. It is called the pointing nodes or markup nodes. There are two things. One is the markup node, which is shows the direction, and another type of node, it is called the data nodes, it having the all sort of information. So basically there are two things here, you see that. So there are two level of trees. One is the, here if we see here, there are two types of trees here, leaves here. One is the key is showing you the direction in which way you will sort the data, you will pick up the search value. And another thing is the data is basically in the lower part. But remember it, all the datas are keeping in the same level, in the same row, but the direction, but the pointer or the markup nodes can be hierarchical, can be what we say that it is can be promoted to the upper level as a root and the other children's, but the data values, the data nodes are all in the same level or in the same line. So the properties, if we say the properties of the B plus tree, if M is the order of the tree, so M, that is mean the how many branches can be possible of the B plus tree, it is M. Every internal node has at most M children. So if the direction is M, if it is a 3 branches of tree, if it is a 4 branches of tree, so there it have the 4 children at maximum, because it having the 4 branches. Every internal node that except the root node has at least M by 2 children, which is we are taking the ceiling values. So if it having the 5, M is equals to 5, then M by 2 is equals to 2.5. So if we take the ceiling value, it will be 3. the root has at least 2 children if it is not a leaf node. Every leaf has at most m-1 keys, that is the rules of B tree. An internal node with k children has k-1 keys. All leaves appear in the same level. So all the leaf node having the m-1 number of keys, and all the internal node with k children has k-1 keys. So if a internal node or a markup node having the k children, so the children has k-1 keys, as like the rules of B tree, all leaves appear in the same level. So all the data nodes all appear in the same level. So this is the algorithm. How can we insert the B plus tree? If you just go through the algorithm, you can easily understand what is basically says is, and this is the deletion of a record from a B plus tree. So we want to see a more details about the B plus tree in the next example. So insertion, if we do an insertion, so assume a B plus T degree is 3, so m equals to 3 here. So if we insert some values 1, 2, 3, 4, 5, 6, 7, all are in the sorted order, so we can say that we insert the values of different values in different steps, like as B tree. So we are seeing here the insert 1. At first when we insert 1, as here m equals to 3, so there will be m-1, that is 2 keys can be preserved in a field. So here you have to remember that there is some data node and some markup node. If there is one data node only, so there is no markup is needed, as like as root node. So whenever the data node is more than one or multiple, that time you will create a markup node. So at first there are m equals to 3, so there should be m-1, so 3 minus 1 equals to 2 number of keys can be preserved in a single leaf. So insert 1, that is the value inserted in the first leaf node. Then insert 2, whenever you want to insert 2, there is a place already here. So this place you can occupy it by inserting the value, second value, insert 2. Now whenever you want to insert the 3, then so 1 and 2, this is already here, and 3 is the another value, but it cannot be occupied in this leaf node because there are only 2 space. So you have to create another node which will contain the value of 3. But whenever you are creating another node, so it need a root node. It need a root node, and the root node is here is called the markup. So it is the another level of node. But in the B tree, if you recall the B tree, whenever the root node is come, one value is split and promote. So here we maintain the same rules, but here we will promote the value, but also keeping that value in the leaf node, in the data node. So here 1, 2, 3, 3 values are here. The median is 2. So 2 will be, we'll split the values in the median. So 2 will be splitted here and 2 will be promoted as a root node, but we will keep 2 also in the leaf node because it is also a data. So basically here, so you see here, that is 2 is splitted and 2 is promoted to the root node or a markup node. There are 2 level of node is already created. This level is called the markup level, and this is the data level. In the data level, all the data should be preserved. From the data, you are choosing one value for the markup and it directed its left that it having the values of less or equals to it, and in the right it having the value greater than it. In the B tree we have the rules of in the left it having the lower value, in the right it having the higher value, but in the B plus tree it is the algorithm that is in the left you can preserve the value it has it less from the markup or equal, in the right side you can preserve the value higher from it. So that is the rule. So if you now insert 4 here, so 4 will be inserted here, that is the thing. So you are inserting 4, then inserting 5, so this image is already here. So whenever you inserting 4, 3 having a space besides of it, so it is just inserted here. So 4 is inserted. Whenever you want to insert 5, so there is another node is created, and by among these 3, 4 and 5, 4 is the median, so 4 is splitted and moving up. So as the 2, just after the 2 we have a space, so 4 can be set here. So all the values are in the same level. This level is called the data level or leaf level, and it is the internal node or the markup level. It is in the upper of this data level. Now we want to insert 6. So if we want to insert 6, so what will happen here? So if we want to insert 6, so you see here the data is like, so after 5 there is a gap, so 6 is already presetted here, and then whenever we want to insert 7, so you see that there is no place in this node, so you have to again split and move up. So whenever we split and move up, 6 will be gone up, so it will create another node. So by these, here you look the main focus, so we will split here. So 5, 6, 7, from the 5, 6, 7, what will happening here? So 6 is less than here and 7 is here, so this is the splitting, but all the data leaves will be preserved in the same level. So 6 will going up, and it will create, after the split will promote like this. So 6, 2, 4 and 6 are in the same level. 2, 4, 6 will be in the same level, and 5 and 7 will be the below level. So we will adjust this like that. So after the promotion, what is happening here? So 2, 4, 6, so that is the 1, 2, 3. Okay, so we will finalize these, that is the 2, 4 and 6. So 4 is splitting here and it is updated. So these level, especially these level, this markup level is following the B tree rules, but all the datas are preserved in the markup level. So all the datas are stored in the data level. So here all the datas are in the same level, there is no up and down, but the markup level having one more hierarchies. So that is the B plus trees rules. So thank you for watching this lecture.